Hi everyone, welcome to this episode of Data Epoch. We have Drone Adhikari here with us today. With over 4 years of experience as a data professional, Drone has been providing his services in data engineering and warehousing solutions. His key areas of interest include working with new data engineering platforms and tools and developing scalable solutions on cloud. Thank you, Drone, for being here with us today.
Thank you. Thank you for having me. It's a pleasure to be here.
So, how and why did you get into this field?
Data engineering has been, I would say, not was my first, forte into data. Right back when I was in college, I used to, work with embedded programming, and that's what actually got me into Python. And yeah, because Python was actually, budding at that time, and also was a primary, language of choice for people who would work in embedded software. And somehow when I was working with my embedded programming and other things, I figured out that one of the most growing sectors where Python was used was for data analytics and data science. And that's what actually got me interested into finding this new field and trying my hands at it. And soon I just realized that it was a very great field to work on. And my interest grew into data science. But as I started working in data science, but my programming, what I would say, my programming experience led me towards data engineering more, because data science requires much more stats and mathematics and probability studies. And being from a programming background, I thought, data engineering suited me well, much more actually. So finally, I shifted my gears from, embedded to, data science, and finally to, data engineering. I even worked as a data analyst first, but I got good companies to actually, offer me opportunities to try and work with data engineering problems. And this is how I actually got into, data engineering.
Cool, very cool. And I think data engineering is also like the first step towards data science, because without having the entire data source, you're not going to be able to do any data science. So it's like very important to have those skills as well. So what is your process of coming
Exactly.
up with an action plan to set up the right data infrastructure for a given problem? And when do you plan for scale in this process?
So, data engineering, as we all know, is almost everyone seems it like, a small part of software engineering that just deals with, ingesting data and manipulating it to finally make it ready to work. But it starts with a lot more planning, actually. We normally, whenever setting up an infrastructure, we try to, first make a high level design and, try to identify different parts of it, like how to ingest the data, where to store it. It mostly comes down to three main questions of where to carry out your processing, how to carry out your processing, and finally, what are you going to do with it? So we try to answer, based on these three questions, and they mostly guide us towards, providing a much more, I would say, complete approach towards defining an architecture. Because once we figure out where we are going to do our processing, it finally, figures out, what kind of formats are we going to work on? Is the data going to be a compressed one, or is the data is going to, which kind of format is the data going to be in? And once you figure out, once you figure out how we are going to do it, it actually, transitions into the questions whether we're going to do it in a batch, whether we're going to do in any kind of stream, are we going to make it a continuous evaluation, or are we going to, work on small chunks of our data? So it's kind of, first figuring out a high level design of how you want to take your data, what kind of processes you're going to run on it, which helps to, lay the underlying infrastructure for it. Because whenever you choose a format for data, it would decide what kind of infrastructure you need to have to store that format. Whenever you choose how to work or process the data, it would decide what kind of programs or tools or libraries you're going to use to work on it. So that's how, what infrastructure is built, by answering these three kind of questions. And finally, when you figure out what are you going to do with it, are you going to serve a dashboard, or are you going to just simply, store reports on any kind of object storage? It finally gives you the architecture of what are you going to finally do with it, like in terms of whether you're going to connect it to a BI tool, or whether you're going to connect it to a simple storage wherein the data is going to be further used by a data scientist or data analyst for their reports. So laying an infrastructure is mainly up by answering, what these three questions about data. And as per scale, I would say it's always good to imagine that your application is going to scale. It's good to plan it right from the start, so that you're not faced with any kind of repercussions later on. So scaling should always be a part of your architecture. It should be at the back of your head, even if you know that it's not going to scale. But you should always keep the scopes of scaling your application right from the start.
Cool. That's a very good framework that you provided there to help decide, the infrastructure and the overall architecting of the data platform. And yeah, it is true that you have to plan for scale from the start because it is pretty hard to, sort of integrate it at a later step when your infrastructure
Exactly.
is not supported. You'll have to rip everything apart and rebuild from scratch. So it's better to avoid it.
Exactly.
Yeah.
And it comes down to data engineers to do that at the end. So it's best we do it from the start.
Yeah, exactly. So, what are some challenges that you face so far in your career, like while you go through these processes?
You know what? Most people would, who are not part of data engineering would, feel, working with the data or trying to figure out what to use or what technology to use, what libraries to use should be very challenging task. But you can ask any data engineer any day, and he would say the toughest part of a data engineer is actually to source the data. We've always, and we've all read articles about how people say that most of their time has gone into, sanitizing the data. And that is true. Actually, figuring out the part where you're going to ingest the data and figuring out the right validation steps to figure out that your data is actually correct for, using is the hardest part. Because, you'll have to actually convert actual business logics, actual business questions into technical language, and then write various tests based on it, just to figure out that whether your data is actually standing up to the absolute mark of quality that you needed. And so that is one of the toughest part, because every different project, every different application requires different levels of standards of quality, and all those requires us to write different kind of tests. So validation of data, having the right data, is the most important part and the toughest part to figure out, because I've seen a lot of time in my team where data scientists were actually busy working with a very great problem, and they spend their whole days or months working on it to in the end find out that the data that they were working on was not up to the mark. And that actually ruins the entire efforts there. And it comes down to us to finally maintain our infrastructure in a way, maintain our codes in a way, in our applications in a way that they source the data correctly, carry out all the tests in a much more robust way to make sure that none of the data is basically garbage for us. So writing those tests is the most important part, I would say, and most challenging one.
Cool. So vendors offer like a variety of data engineering solutions, right? Both private cloud or public cloud, and we're often like spoiled for choices. So what is your framework to like decide on the best choice out of all of these?
Okay, so this is the part that kind of builds into what our previous question. I mean, how to figure out what to ingest. So vendors do provide us, a lot of choices to work with data. But if you actually not listen to what AWS says, AWS in their documents, in their white paper says it talks about a well-architected framework. And one of the keystones of a well-architected framework in AWS is to operationalize your infrastructure in a way that your operational costs are actually efficiently managed. So even AWS does not say to use any services and just throw in services in your infrastructure and build your infrastructure based on all kind of things. It's very important to identify when you need to use which kind of service. And it comes down to like the building blocks I said, it comes down to understanding your architecture in a high level design, and then you can actually analyze what part of what particular architecture could be very well be beneficial to be used by AWS. For example, if you have a storage layer, it's important to see whether your on-prem storage layers would be as good as the AWS any kind of storage layers that you have, where your database services would be as good as the database service from the AWS. And that's how once you break your application into different chunks, it gets easier to identify what kind of services could actually be beneficial to be used from AWS, and what kind of services could be beneficial to be used by us. because you know what, I'll tell you a very interesting use case. I've recently seen one. I saw a recent project, and where the team was working, and they have their entire infrastructure set up on cloud. It was all good, all classic, latest techs, latest I would say services from AWS and Databricks used up. But they took a very interesting experiment into they carried out a very interesting experiment, and they just try to decouple their entire infrastructure. They try to make it much more microservice oriented rather than a single application. And what they found out, that there were a lot of pieces in their application which actually never needed to scale out. They never needed to be scaled in any way, and they were just simply using services from cloud vendors to carry out those operations. They were using actually services from cloud to carry out those operations. So what they did is, once they have actually decoupled the entire application into simple microservices, they actually wrote some of those services on their own using their simple programming languages, and just set it up on a VM, and it works finely. What they did not need was just simply throwing services into picture just to carry out work. So sometimes it helps to actually decouple your entire application, see what parts needs to be scaled, but also to see what parts would never be needed to scale, because it needs to be we need to understand both part of the equation, what needs to be scaled, but at times what may never be needed to scale. So, and that part we can actually simply code on our own, make a in-house small service, in-house service, and simply deploy it over cloud to be used, and not used directly the services that are given by cloud vendors. So, and it's given in AWS's well architected framework also. So it's required that we understand that we should not be just simply using the services. We should use a very well judged approach to what services we need to use and what we need to scale.
Do you think this is like sort of a bundling trap that is going on currently, because there are managed services or like recommended architectures, and people just follow it because they want the easier solution, or like sort of like plug and play rather than having to design everything themselves?
Yeah, it's basically, it spoils us to the point, because we want to use all the services that are simply given to us. It's easy to set up, it's easy to scale, you don't have to provision at the end. People say a lot of things, but what it does ruins is in most cases it's your cost budget for the application that you've set in. So as an architect, I've had discussions with good data architects about this, and almost all of them say it's very important to to understand the business case that you're serving, and identify only the parts that needed to be used, because you just cannot simply throw in architectures and just assume that your problems are going to be solved. You need to keep things much more oriented towards cloud, which are required to be just set up on the cloud. A lot of things that do not need to be scaled, do not need to be set up. There are things which you can optimize much more if you have control over it, because as soon as we start using services from cloud, we lose a lot of control over the services. We lose a lot of control of how we operate it and how we build it. So it's good to keep a sense of control in your hand while using these services.
Cool. So tell us about a really cool project that you worked on and that you're also proud of contributing to.
One of the most interesting projects that I've worked on was not actually a commercial project. It was basically a research experiment that my company was conducting. So we went out and we thought about creating our own data warehouse. So data warehousing was a big requirement for any enterprise if they want to make operationalize their existing data into much more economical way, if they want to cash in on the data that they're having. So we thought about actually creating our own data warehouse, and we were actually experimenting between a data warehouse that was based on simple RDBMS databases, or a data warehouse which was based on NoSQL databases, a document database basically. And so what we did was we actually created two large data warehouses based on two different technologies, and we benchmarked them against each other using query plans and structures. We carried out different type of storage methods to see what kind of storage methods and partitioning and indexes would work best for them. And it was a very interesting project, because it first of all, it led us to read a lot of research papers on both those structures, and identify a lot of problems that we could see and what normally these databases struggle from. And in the end, what we found out was that as long as we are ready to optimize any database to the to their core storage functions, to how the data is stored, how the data is basically arranged, and what kind of data structure we use with them, we're able to actually carry out a good amount of, I would say, performance from both of those databases. So it was a very neck to neck solution, neck to neck, I would say, competition among both kind of solution. But yes, there were parts wherein the document storage was actually performing better than the relational one. There were parts where the relational storage was performing, database was performing better than the document one. And so it all came down to the use case that you want to serve, whether you want to have more flexibility and keep both structured and semi-structured data and be able to use over it, or whether you just want to structure your data completely. And if you don't have a use case for any kind of semi-structured or unstructured data, the relational database could very well suit you. But if you want to keep more flexibility into your hand, you might as well go with the document database. And it would come down to how you organize your database, what kind of I would say the data structure that you use to organize your data, which actually would play a big hand in making a data warehouse which is efficient. And it's very much possible. There are good data warehouses outside, but it's very much possible to make your own. But it's good to have a hybrid approach towards it. That's what we found out, to keep yourself both flexible and performant.
Well, so far, like I think the pattern of what we've been discussing really just comes down to like the objective or like the end goal of different data projects are different, and so we should keep that in mind while designing or architecting the data pipelines. So is there a common framework or set of steps that will help us ensure that the objective of the data venture is fulfilled? And what are some common key areas while working on such ventures that you should look out for?
So, well, it's a good question actually, and I would say I had a very good discussion about this in one of my discussions in Teams with an architect, and what I got to learn and with my past experiences, it's very important for an engineer, as an engineer, not only data engineer, any kind of engineer, even a software one, or even if he's into what other streams, it's very important to understand the use case or the impact that they're trying to serve. For example, whenever as data scientists, if a data is served to you, it's often said, here you have a flights data, here you have a data from an experiment. They always give you some kind of a background to it so that you can understand the data, because there are going to be some common sense questions when you're dealing with the data that you'll have to answer them. For example, you'll have to see what kind of assumptions you can make about the data, and you can only make those assumptions as long as you understand where the data is coming from, what the data is going to be used for, what is the question, the real life question the business question we are going to answer with that data. So it's very important to understand where is your data sourced from, what kind of customers that contributed to it, what kind of application that collected it. So once you understand, have a I would say bird eye view of the infrastructure that was behind collecting that data, or the application that was behind collecting data. Once you understand the questions that you're going to answer, you will get a much more good sense. You will be much more encouraged to make sure that you write good objectives for yourself, because it's very important while working on any kind of data project to write good milestone or objectives for you, that I want to achieve this type of accuracy or quality by the time we have processed this much data for this place. So it's important to write those objectives, and you're only able to write those objectives when you know the answer that you're going to give. If you know that, for example, your data is going to impact a particular decision, you can actually break down your understanding about it and establish various milestones and keep those milestones as your performance indicators. And while you're working with it, you can keep going back to them and check them whether I have actually fulfilled this amount of quality indicators from my data. If you know that your data has actually served the purpose for particular quality indicators again and again, that at the end when your data comes out finally is used, it would be serving the purpose that it is meant to. Because in the end, no matter how much engineering or data science we put in, if we are not actually solving the real question that we were meant to, I don't think so, all our efforts would be of any use. So it's important to, establish key performance indicators, understand what your data is meant to do, and keep going back to it again and again to check, okay, is my data is up to the mark, will it be able to perform at the quality that I want as per the performance indicator that I have established. And if it actually qualifies all your performance indicator, at the end it would always be a much more qualified data. It would help a lot of people, not only your team but the other teams that are going to use downstream from you, because as a data engineer, your the data that you're processing is finally going to be used by other people. And whatever you make, if it is not at all making sense to other persons, your work is not kind of that much making an impact. So it's very important for us to understand what my work is going to be used for. So it requires communication between different teams. It requires communication with the analysts that are going to use it. Requires communication with data science team that are going to use it, and understand what they actually want from it. Once you understand what they want from it, you can actually establish your own performance indicators, that okay, I want at least this type of test to be passed by my data. I want this kind of sanity to be there, this kind of quality to be there. And once they pass that, you are very sure on your end that it would make the impact that it requires. And that's how these kind of things actually help you to pinpoint any kind of pain areas that you're having. You can discuss them further, and it helps into make your project more successful on a team level. It's not only writing your own code and going back home. It's about contributing at a team level to understand the problem that you're going to solve. So that kind of communication is very important in understanding, and making sure that your data venture has served its purpose. It's key to success to any kind of what I would say software application, and it's very much true for data engineering as well.
Cool. But with the current scene where all the companies or any sort of establishment is just collecting data for the sake of it, thinking there will be some hidden gem in it. At that point, I think it is very hard for data engineers to know how exactly it's going to be used. But like once they have some use cases curated by the analysts and sort of POCs are developed by the data scientists, you're mentioning that we have to go back and iterate to develop key performance indicators so that the data engineering platforms are also in line with the overall goal.
Correct. So it's important to, like I said, communication is one of the key factors here. You need to communicate well with the other teams. You need to understand what are their expectations of you. They should understand what are your expectation of the what work that they expect of you. And once that communication channel is there, you are able to perform as a team to get the things out of data. And even in those cases, even if the data does not make much sense in the start, you're able to find out some of the insights, because you're right in the way that companies are actually aggregating data, just collecting it, and just think that data science is actually going to solve all their problems, which is not always the case. I mean, like you need to have good amount of data, good amount of understanding of the use cases that you're serving. And yes, data science teams actually work a lot on it. I know, I've seen, like I said, I've seen people working hard on and just failing because they could see that the data was not up to mark. So that kind of communication, if you have between other teams, you can actually curate your data well, curate your tests well, curate your validations well enough in place before, so that other teams are having less troubles to deal with it.
Yeah, I think we all have to sort of come up with a common language and common framework so that we're all on the same page rather than working in silos and being in completely different worlds. Yeah, that's a
It hurts the most.
great framework. Yeah. So finally, tell us something outside work that you really enjoy and get inspired by.
One of my key inspiration is to keep trying to learn new things. I would say I do play sports a lot, and to use a sports metaphor, it's very important to keep up your preparations, your practices well, to perform again and again. It's very important not to win one trophy, you have to keep winning others. So it's very important to keep learning. It's very important to keep up with the trend, because trends in data science, as we have seen, they work a lot quicker. I mean, like just in last 7 years, we have seen a lot change in the data scenarios. Spark was not much used in 2013 by the time I was in college. I mean, like an Indian scenario, but now we are seeing Indian IT companies and companies all around the world, even in Europe, are now actually using data engineering as they are giving much more importance to data engineering. So, and data engineering was not in the landscape by 2 years earlier. So, 2 to 3 years, or even I would say around that time, it was not that much of a scenario, but it's a very hot areas to work for. So the scenarios keep changing. We have to keep ourselves updated with it. We have to keep learn new things of it. Um, Cloud vendors would actually come up with new services. AWS has more than 200 services. So I mean, like, you just cannot expect yourself to be, not always be ready for it. But the good thing is to keep up with their, their events, webinars, and keep learning so that you are able to work with the newest technologies. Because one thing is that you may not have all the answers as soon as you start. But good part is that data engineering and data science, these kind of fields, they teach us to actually, keep working at it, because much of our job is to actually figure out the things as we are doing it, not to have the answers right at the start. So this is the thing that actually keeps me going at it and keeps me inspired about doing this.
Cool, very cool. So this has been very insightful, and I think we've identified like a very important need here, that we all need to develop common language, common communication frameworks, so that we work together better rather than repeating efforts, or like any team going into efforts that is not fruitful to the other, or not understandable or consumable by the other. So thank you
Exactly.
for this wonderful podcast.
Thank you for having me, Sandra. Thanks.
Right. Bye.